Right, and we'll do this example as well. So once again, if you want to have a go at it yourself, pause the video and go away and have a look and see if you can work it out, and then come back because I'm about to do it. So here we go. So again, I've just written the system of equations as an augmented matrix over here, and this one's quite nice, and it's already got a 1 up in the top left corner. So all I really need to do to get started is my row 2, I want to take away 2 lots of row 1. So I'm going to start with my original row 2 and subtract 2 lots of row 1 and make that row 2. And similarly for row 3, I want to take off 3 lots of that 1. So row 3, I'm going to take off 3 lots of row 1 and make it a new row 3. So row 1, I'm not changing at all. Row 2, I'm taking away 2 lots of row 1. So 2 take away 2 lots of 1 is 0. Surprisingly, that's why I chose it. 1 take away 2 lots of negative 4 is 9. 2 take away 2 lots of negative 2 is 6. And 3 take away 2 lots of 21 is negative 39. And then I'm going to do 3 take away 3 lots of that is 0. 2 take away 3 lots of 4 is 14. Negative 1 take away 3 lots of 2 is going to give us positive 5. And negative 2 take away 3 lots of 21, that's 66, and negative 65. Okay, and then what I'm trying to do now is get a handle on this 14. I'm going to have to do it with 9, so I'm going to have to make 14 and 9 make 0. And personally, I just divide this row here by 3. They all divide by 3. Might as well get it down to an easy number to work with. So I would just go row 2 over 3 to replace row 2. So I just leave my row 1 exactly the same. Divide row 2 by 3 and leave the bottom one the same. That's an optional step. You can do whatever you like basically as long as you follow the rules, but sometimes it becomes a little bit easier if you just do a little bit of manipulation in the middle of it. So now what I want to do is I want to do 14 take away some lots of 3 to make this one equal to 0. So I'm going to start with my row 3 and I'm going to subtract 14 thirds of row 2 and make that the new 3. So row 1 and row 2 are completely unchanged, and now I'm doing 0 take away 14 thirds of 0, 14 take away 14 thirds of 3, which comes out to be 0, and then we're going to do 5 take away 14 thirds of 2, 28 thirds. 5 is 15 thirds, so 15 thirds take away 28 thirds is negative 13 thirds. And then we're going to do 65 take away 14 thirds of 13, which is going to be a bit of a mission. So 14 thirds, 65 and thirds, so it comes out to be negative 13 thirds as well. You may want to do a little bit of check that I've got that one right. So what I was doing there was negative 65 take away 14 thirds of negative 13. So just double check. So using a calculator is quite often a good idea. You may have to do that. But I now have the whole thing in reduced echelon form, so I can go and do my back substitution. So substitution, well, the first one's really easy because it's just telling us that this lot of z's equals that. So they're the same, so z obviously has to be 1. For the second one, I'm telling us that 3 lots of y plus 2 lots of z, which is 1, is negative 13, which means that y has to equal negative 15, so negative 15 divided by 3 is negative 5, and for the z, for the x, which is the top row, so x minus 4 lots of y minus 2 lots of z has to equal 21, which means that x equals 21 plus 2 minus 20, which is 23 minus 20 is 3. So the solution is xyz is 3, negative 5, 1 as the solution to the system of equations that we started with. And that one's got a little bit more mucking around in the middle. We had to do something with fractions in the middle and a little bit of a slightly nastier calculation going on here, but it may or may not, depending on what you like, be easier for you than doing it by an inverse matrix. So you have two methods, inverse matrix method and this Gaussian elimination, to solve systems of equations. It's up to you as to which one you use.